Hello everyone, welcome back to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Punguri, your math tutor from C.D. King Higher Secondary School Science Stream, Jotsama, Kohima. In this session, we are going to continue with derivatives of composite functions. The famous name is chain rule, isn't it? So here, what is this chain rule and composite functions? Just I'll give you one example, it will be easy for you to understand. Sometimes we receive gifts from our friends, big carton, isn't it? Then when we open it, there will be another carton. Then again when we open it, then we will find one more. Then slowly, then finally we will find a small carton, that is the gift, isn't it? So to reach that small carton, we have to uncover the bigger one, the biggest one, and then again next level, next level, next level. Similarly, we are going to open up the function which holds all the functions. Then first let us break that chain. Then we will get inside. Then we break the next chain. Then we get inside. Then slowly getting inner and inter, and then we get the main function. So in that way we are going to do it. That's why it is named as chain rule. Alright. Then composite functions you have already studied. Suppose if you take a function fx as x squared minus 3, then gx as sine x, then how do you find out GOF? Which we have seen already in the second chapter, inverse functions, isn't it? So g of x is g of fx. So this can be computed as fx is x squared minus 3. This will become, then you replace x with x squared minus 3. So you get sine x squared minus 3. If you see here, this function is inside this sine function, isn't it? So this sine function is holding that x squared minus 3. So first we will remove that chain, we will break that chain. That is, first we differentiate sine and then we will get inside this x squared minus 3, then we differentiate this one. Is that clear? Okay. Now, mathematically, if you take u as a function of t, and then this t, if this t is a function of x, gx, but I want to differentiate this u with respect to x, that is du by dx. So how do we do? But this u is a function of t, then t is a function of x. If you want to directly differentiate this u with respect to x, so we have to go with two steps. First of all, we have to differentiate this du or df of t, it's up to you, du by dt multiplication. That is very important because most of the students, they put plus, minus, division, whatever they like, but that is all not correct. Into multiplication only we have to put into, then dt by dx. So you will automatically get du by dx. We can further extend this to more composite functions, like if I take u as f of t and t as g of v, and then v as h of x. Suppose if you want to differentiate u with respect to x, so we have to cross the 3 levels. Like games, we have to cross the 3 levels. So du by dt first, and then multiplied by dt by dv, then dv by dx. Alright, then only we get du by dx. So this multiplication, don't forget, this is very important. Okay, let's see some exercise problems for this kind. And here I have written some list of derivatives. This one you have studied already in class 11. It is not just we are writing here. Okay, it did not come out some nowhere. So, no, it is not like that. We have to use the first principle to find out this derivatives. It is ready-made. Okay, you have to just keep in your mind to find the derivatives. Okay, then let's move on to the exercise 5.2. This is your exercise 5.2 in your textbook. The first problem, sine x squared plus 5. Let us take this function as y equal to sine x squared plus 5, right? If we differentiate this function with respect to x, we get, see, please don't directly start giving the answer. You have to write these 2 steps. Let y is sine x squared plus 5, differentiating with respect to x. With what variable you are differentiating, that should be written. Okay, then only it shows your clear answer. Differentiate with respect to x, we get dy by dx. It's a composite function, so we are going to do this chain rule. The sign is holding this x squared plus 5, right? So first we have to differentiate this sign. Okay, derivative of sign is cos x, isn't it? So therefore this becomes cos. Here in place of x we have x squared plus 5. So it will come as it is, x squared plus 5. Then we will get into this function. So we have to differentiate this with respect to x squared plus 5. If you are confident enough to do the derivative at one go, it's okay, no problem. But for your better understanding, I am writing the steps. So cos x squared plus 5 into, if you differentiate here, sum of two terms, right? Sum of two functions. So we have to differentiate separately. Okay, so x square, what is the derivative of x square? By using this formula, d by dx of x square is, you bring the power in front of it, right? So 2x power 2 minus 1. So that is 2x to the power 1, that is 2x, right? So it is easy to remember that you bring the power in front of it and reduce the power by 1. It is easy for you. See, 2x it will come. Then if you differentiate x cube, what do we get? In one step we can write. You write the power in front of it, 3x, then the power will be minus 1, 2. Okay, every time you don't need to remember this formula and then find out. So if you can do it for 2, 3 polynomials, you can easily find out. Then what will happen to x? We are differentiating x with respect to x. So it is 1x to the power 0, right? So x to the power 0 is 1, so you will get 1. So you remember that whenever we are differentiating a variable with respect to the same variable, we get 1. Okay, and what will happen to 1 by x? 1 by x. Okay, so here we have to bring this one to the numerator first of all. When there is a variable in the denominator, you have to bring it to the numerator first and then you differentiate. So it becomes minus 1 x to the power minus 1 minus 1. So that is minus 1 by x square, right? So if you practice for few questions, few x terms, then it will be easy for you. Then if you have a root, for example, d by dx of root x, how do we differentiate this one? So we first write this root in terms of power. So you get d by dx of x to the power half, right? Then you differentiate automatically in the similar way. So it will be half into x to the power half minus 1. So that is minus half. So you will get 1 by 2 root x. Okay. So if you, the basics are very important. If you are clear with the derivatives, then you can do any type of differentiation. Here only you people are getting stuck. First of all, make yourself very clear with these derivatives. Then you will enjoy doing this. Okay. So x square differentiation is 2x, okay, plus 5. 5 is a constant, isn't it? 5 is a constant. So what is the derivative of constant? See, for constant, derivative of constant is always 0. Therefore, this will become 0. So you get, I'll write this 2x in front of it, 2x cos x square plus 5. That's all. Okay, we'll see one more. Okay, here the next problem is secant tan root x, right? Then first let us assume this one as y. Y or fx, it's up to you. Secant tan root x. So we are going to differentiate this with respect to x. We get, so dy by dx is equal to, here which one we should first uncover? Secant, right? Because this is the one holding these two, isn't it? So first let us differentiate this one. Let us cut this one. Okay. So secant, what is the derivative of secant x? Derivative of secant x is secant x tan x, right? So you treat this one as x now, as per our derivative. Secant x is secant x tan x, right? So you will get secant, in place of x we have tan root x into tan root x. Hope you understand this one, right? So derivative of secant x is secant x tan x. Okay, in place of x we have tan root x, so we put here tan root x, tan root x. Then we will get inside, that is we will differentiate tan root x. So d by dx of tan root x. I'll put multiplication here. Then this is secant tan root x into tan root x. Here again, tan holds this root x, isn't it? This root x is inside tan. So first let us open this cover. Tan, we will cut out and throw it away, this tan, no? So if you find the derivative of tan x, what do you get? Secant square x, isn't it? So here in place of x we have root x, so we replace this x with root x. So you get into secant square root x. Clear? Then what we have to do? Now this is our last function, root x. We have to differentiate this. So d by dx of root x. Okay. So this will give us secant tan root x into tan root x into secant square root x into d by dx of root x. Just now I have showed you root x will be taken as d by dx of x to the power half. If you go with the first one, you get half into x power half minus 1, that is minus half. So it will be 1 by 2 root x, right? So derivative of root x is 1 by 2 root x. So this is 1 by 2 root x. Okay, so just we have to arrange the terms, then you will get the book answer. That's all. Okay, the third question is sin ax plus b by cos cx plus d. Right, a, b, c, d are constants, x is the only variable here. Okay, here there is a function in the numerator and also another function in the denominator. So it is by the quotient rule we have to differentiate. Okay, so let y is equal to sin ax plus b divided by cos cx plus d. Okay, so what is the quotient rule? D by dx of, or u by v whole dash. Let me write that one, that will be easier for you to remember. So u by v whole dash is equal to v u dash minus u v dash by v square. Here you don't change the order because subtraction is not commutative, right? So 2 minus 3 is not equal to 3 minus 2, isn't it? Therefore v u dash minus u v dash. In case of addition you can interchange, no problem, by v square. Okay, if you compare this with here, you get u as sin ax plus b, right? And v is cos cx plus d, right? So let us find out the u dash, that is differentiating with respect to x. So you get here this sin holds this ax plus b. So first of all let us differentiate this sign and then we will get inside this ax plus b. So if you differentiate sin, you get cos x, right? So cos ax plus b, right, into, if you differentiate this part, ax, if you differentiate, what you get? If you differentiate 2x, what do we get? 2, that is lambda u dash whole dash is lambda u dash, right? This constant, you take it outside and then you differentiate only the function, isn't it? So this 2 will be here and d by dx of x. I already told you when you differentiate a variable with respect to the same variable, it gives you 1 as per this derivative, right? So it will be 1. So 2 into 1, 2, right? Not only 2 with minus 2 or minus 3 or 1 by 2 or 1 by 3. Okay, when there is a constant with the multiplication of a variable or it is in the division, the number will remain the same and this x will become 1. So you will get only that constant. You can remember like that. So here ax, in place of 2 we have a. So you will get a again, right? And then b plus b. This is constant alone. There is no x along with it, right? This should be treated as separate terms. Yes or no? and here it will become 0. You will get confused with why here it is not becoming 0, but here it becomes 0, because there is a variable along with this a. So it will not become 0, it goes with this algebra, okay. But here there is no variable, so it becomes 0, okay. Then here v dash will be, differentiation of cos is minus sin x. So minus sin cx plus d into, now you can easily say that, into c, isn't it? So we will substitute in this formula here. So differentiate with respect to x, we get, so dy by dx is equal, dy by dx or y dash or y1, whatever you like you can write, whole divided by v square is cos cx plus d whole square, okay. Then v u dash, that is cos cx plus d, v u dash is cos ax plus b into a plus 0 is a, right. Then again I'll rub this, minus u is sin ax plus b into, if you can remember the v dash, that is minus sin cx plus d into c, right. So that minus into minus will become, if you want I write again, okay. So minus u v dash, u is sin ax plus b, v dash is minus sin cx plus d, right. It is in the product, therefore it will become plus here. So sin cx plus d into c. So this is your book answer, that's all. The next problem is cos x cube into sin square x to the power 5. So let us take this as y equal to cos x cube into sin square x to the power 5. Differentiate with respect to x, we get dy by dx, right. If you notice this is a product of two functions, cos x cube and sin square x to the power 5. So what is the product rule? u v whole dash is u v dash plus v u dash, right. So here u is cos x cube and v is sin square x to the power 5, right. So what it will be, u dash. So it is a composite function, right. X cube is inside the cos function. So first let us derive this cos. So it is minus sin x cube, because derivative of cos is minus sin x cube into, now you differentiate this x cube. What do you get? 3x square. You put the power in front of it and reduce the power by 1. So 3x square. And v dash will be here sin square x to the power 5, right. So which holds this function? Which is the first one we have to uncover it? The square, because the square holds everything, right. So sin, it can be written as sin x to the power 5 whole square. Yes or no? So first we have to remove this square, then we will get inside this bracket, and then we find the derivative of sin, and then we will differentiate x to the power 5. Please take note of it when there is a power. If there is a root also, first you have to differentiate the root, okay. So this 2 will come in front, then sin x to the power 5 whole to the power 2 minus 1, yes or no, n into x power n minus 1. I am derivating only this, I am differentiating only this power first, then we will go inside this sign. So derivative of sin is cos, so cos x to the power 5. Then differentiating x to the power 5, you get 5x to the power 4, right. So this is the derivative of v dash. So now let us substitute here, that is u v whole dash will be dy by dx equal to u v dash, u is cos x cube into v dash is this one, right. So 2 5s are 10, 10 x to the power 4 I will write here, then sine x to the power 5, 2 minus 1 is 1, so we don't need to write the power, then into cos x to the power 5, then plus v dash, v is sine square x to the power 5, and u dash is minus is there, right? So this plus into minus becomes minus, then let me write this 3x squared in front of it, 3x squared sine x cubed. So this can be rewritten as 10x to the power 4 cos x cubed sine x to the power 5 cos x to the power 5 minus 3x squared sine square x to the power 5, then sine x to the power 3. So this is your book answer. So now you have learned what is a chain rule and how to differentiate it. So you can do similarly the remaining exercise problems. In the next session, we will learn how to differentiate implicit functions. Thank you.